Hello world, welcome back to this tutorial on building a Linux from scratch system. Now in the last video we've started really building the final system, and yeah, it took quite a while and we didn't get very far yet, but that was mainly because well, the glibc library is so big. Yeah, I really want to install a bit more than 6 packages this time. So yeah, let's just jump right back in. Yeah, I want to pick up a bit steam, so one thing that I will do now, which I did in earlier videos also, is I just want to create all these files in batch, these shell script files. So we have already had the packages man pages, TCL, expect, déjà gnu, iana, etsy, and glibc. And I've also already created the file for zlib. And now I will just create empty files for bzip2, xz, std file, readline, m4, bc, flex, bin utils, gmp, mpfr, mpc, utter, acl, libcap, shadow, gcc, pkg config, ncurses, set psmisc, get text, bison, grep, bash, libtool, gdbm, gperf, expat, inetutils, perl, xml parser, intel tool, autoconf, automake, kmod, libelf, libffi, OpenSSL, Python, Ninja, Meson, core utils, check diff utils gnu org. Find utils grub less gzip IP root kbd for keyboard lib pipeline make patch mandb tar text info and vim. Now there are more packages in here, but the remaining packages are specifically for system v init, and after we've done these packages here, I want to split this video series in two directions. One where we use system v init and one where we use system d. So that's why I will only go this far for now. Okay. So now I've created all these files. Okay, the code for zlib is already there. So I'll just do some of them. I had these problems with M4, and just to avoid that, I will just take the workaround that I had before. Okay. And this is a useful list, so I'm gonna copy that here. Okay. Okay, all these things are installed already, so I will just go into the change root again and try installing these 7 packages. Okay, so while this is still running, I mean, let's talk about the packages that we are installing. Man pages. Well, that's contains the man pages. Very surprisingly, what are man pages? They are like documentation or help files for over 2,200 things. I think including source codes, some header files and so. TCL, the tool command language, that's a script interpreter. It's a relatively high level one, as far as I know, and I'm not sure why we even have such a high level thing in a low level system like Linux from scratch, but okay, they are doing it. I think in the future I might change my script and just throw a few of these things out that I don't think are really necessary, and maybe I can get the system even smaller like that, but we will see. So TCL is definitely something that I think I might want to remove. We need TCL for expect, the next package. Now expect is a program that is used in some auto tests. So you run something and you tell it to expect this or that output. I think if we throw out expect, well, we won't be able to do several auto tests, but maybe we can live without that. And then we might be able to throw out TCL and expect. Deja GNU is a framework for running auto tests. Ayana Etsy is two files, services and protocols that are stored in Etsy. These are just lists of TCP ports and protocols. So, for example, if I think in the UFW firewall, you can tell the firewall, hey, open the HTTP port, and then that firewall would look into one of these files and see, okay, the HTTP port is 80, so I need to open port 80 now. glibc is a very central library that's used in many programs. For example, it handles the locales, stuff like which character is used for decimal separation, or how to format date and time strings. It's a very important library. I think without a glibc, basically nothing would work. So that's something that I'm not throwing out in the future. zlib is a library for compression, zip compression. Then bzip is a compression tool. xz is another compression tool. zstd is another compression library, I think. Okay, it also installs a few programs. File is an interesting program. In Windows, when you open a file like a JPEG file, then Windows will just look at the file extension .jpg and will then look up, okay, JPEG files are opened with some image editor or image viewer. On Linux, the systems tend to do that also in Linux systems these days, but the file program allows you to go a bit deeper, because the file tool also looks at the magic numbers at the head of files, and so even if your file extension is wrong, then the file util might be able to fix that. So a Linux system might say, okay, this file is named whatever, something.mp3, but according to the header of the file, this is a JPEG file, so I'm opening it in an image viewer, maybe. So let's see. So, for example, file gccsh would tell me it's a C source code. Okay, the C source is wrong, but ASCII text, that's correct. Sometimes it just guesses something. But ASCII text, it also can determine the encoding of a file pretty well. So that's also pretty good when you're having any trouble with encodings. Using file, you can usually determine the encoding that's used, and then maybe run your program or run your text file through iconf to convert the encoding. Okay, readline, that's a library for interacting with the shell. So when your programs read a line from user input, that might use this lib readline. It also features lib history, which allows you to scroll through your history with the up key. Okay, M4, that is a macroprocessor, so something like the C++ or C preprocessor, something that expands macros. Many projects don't write their make files explicitly. They write M4 scripts and run them with, or maybe even create them with automake and autoconf, and that then generates your make files. Okay, then BC is a text-based calculator. So you could say something like 1 + 1, and it will tell you 2. I think you can also set variables. Yeah, so I set foobar to 2, and then 2 + 3 is 5. Okay, that's BC. Flex. Oh, I love Flex. I write a lot of compilers. When you look at my homepage, there's so many things that at least parse some stuff. And well, Flex and Bison are basically the most useful tools out there to help you create parsers. So Flex takes an input stream like a file and turns it into a token stream, an annotated token stream, and according to the rules that you write. And then Bison creates a parser that uses these tokens. So instead of that would lead too far. I might actually make a video series about writing a compiler in the future. So if I do that, then we will be talking about Flex and Bison. Definitely, absolutely, certainly. Okay, binutils. Binutils contains, well, for our purposes at least, the very important tools LD, which is a linker, an assembler, AS, and some other stuff like readelf or nm, which allow you to look into object files or binary files. Yeah. Okay, GMP is a library for math that's used by GCC and possibly also the stuff GCC generates. MPFR, another library for multiple precision math, also used by GCC and the stuff GCC generates. MPC, arithmetic of complex numbers with arbitrarily high precision and correct rounding of the result. Another math library used by GCC and the programs they create. Utter contains utilities to administer the extended attributes on file system objects. So it gives you the utter program that allows you to set attributes on files. ACL. Okay, ACL is for access control lists. When you run on your machine only, it's probably not something so important if you have just your user and the root user. But ACLs can be used to set different access rights for different users, right? So, and if you only have one user, such as me, usually, then you don't really care about ACLs, but in a larger environment, that's very important to be able to give people different levels of access to different files. libcap. Well, the description in the LinuxFromScratch book is pretty vague. It says the libcap package implements the user space interfaces to the POSIX capabilities available in Linux kernel. These capabilities are a partitioning of the all-powerful root privilege into a set of distinct privileges. Yeah, I'm not sure what they mean by that, and the Google search didn't turn up much more, so it seems to have something to do with access rights. In particular with allowing normal users to do stuff that would normally only be allowed to root user. Shadow. Well, Shadow is for the for logging in, managing users, groups, passwords. I think having libcap between ACL and Shadow, I guess that tells us a bit about libcap. Shadow, and then GCC, of course, is the GNU compiler collection, the C compiler, the C++ compiler. That's one of the most central packages in the Linux world. And how far have we gotten? MPC utter. Okay. Then let's install these for Okay, Shadow seems to have accepted my root password. Okay, I didn't expect that necessarily. Okay, that was pretty quick. Now we are already at GCC. There were a lot of messages when I built GCC that said fail this, fail that. I'm not sure. It looked like something related to auto tests, and maybe these were auto tests that were supposed to fail. Anyhow, I will just continue for now because I just want to get through this chapter, and yeah, so now I've copied everything up to and including 834, which is a bash, and I think that's a good point for a little break here. So package config. Well, the book says the package config package contains a tool for passing the include path and or library paths to build tools during the configure and make phases of package installations. Yeah, I don't know, that sounds a bit extensive to me to have an extra program for that. I'd say that's something part of the whole autoconf, automake, auto tools ecosystem. Okay, ncursors. That's a pretty big library. It's there to control coloring and positioning of the cursor in a text window. So if you remember the old days, the old Ball and C++, you might remember the con.io header file, and yeah, ncursors is similar. It does similar things, and you possibly don't remember that old compiler, and I'm getting old. Okay, SED, yeah, that's a great program, one of my favorite programs. I will just show you a little bit of what you can do with it. So you know Linux streams, I hope. And well, with the echo command you can write something to a stream, and then you can pipe that, but it doesn't have to come from echo, it can be any stream. And SED is a stream editor, which is probably one of the 3 programs that I use the most on Linux systems. And SED is used to edit the stream, as the name suggests. So for example, I have the word foobar here, and S is a replacement command. What do I replace? Let's say 2 O's, and let's replace it with 2 A's. Okay, so then you get foobar, and well, the G here just means if you don't have that G, you will only replace the first occurrence of the thing you're searching for, and with the G you're looking for global replacement, so then you replace all occurrences. Like here I'm only looking for one O, so only the first O is replaced by an A, and here both are replaced by an A because I've used the G here. SED is extremely useful because you can search for anything, any regular expression. You can have capture groups and reference them in the resulting thing. It's really, really useful. One thing I want to mention, most people use slashes to separate the search term from its replacement, but that's actually not necessary. You can use any character you want, just the next after the S is what will be used here. So I can use colons, for example, and it will also work. That's something that apparently many people don't know, but yeah, that's... and of course you can chain these things, like okay, so that's the stream editor. As I said, extremely useful in scripts. PSMISC, well, it's for management of processes. You know, PS is shows you the running processes, and PSMISC, some other stuff related to PS, like PS tree, that shows your processes as a tree, where something is a parent of a node if that process has spawned that other node process. So that's in PSMISC, for example. Kill all is in there, which you use to terminate programs. Get text has to do with internationalization, so translations of programs to different languages. Bison, as I've already mentioned when I talked about flags, is a parser generator. So when you're writing a programming language, you are definitely using flags and Bison. Well, not definitely, but there are other parser generators out there. Some people actually insist on writing their parsers by hand. I absolutely don't understand these people, because Bison and flags are so good at what they're doing. Yeah. Okay, grep. Well, I just mentioned grep already when I talked about set. Now, let's see. Oops. Now, grep is a bit similar to set in that it reads its standard input and manipulates it and then writes the result to standard out. So, but grep really only makes sense when you have multiple lines, so that's why I'm using this echo command here, which generates 3 lines. And grep, just like set, also accepts a regular expression. And for example, let's say BA and an arbitrary character, so that would match bar and buts, and that's really a filter for what comes through. You know, we have foo, bar and buts, pipe it through this grep BA something, and BAR matches BA something, and BAZ also matches BA something. And yeah, again, regular expressions are a very powerful tool, and I don't want to talk about regular expressions too much here, but you really should know regular expressions. And if I actually make another video series about compilers, chapter 1 is going to be about regular expressions, so you really need to know these. Yeah, one thing, grep-v inverts the results, so grep-v says just remove everything that matches the term. So here we only get the first line foo because that is the only one that doesn't match. So these are, this is grep. Again, a very useful tool. And the last package that I'm doing right now is bash. Yeah, what should I tell you? Bash is the born again shell, and yeah, pretty much the absolute basis of a Linux system. So it's your command interpreter. When you boot a Linux system, at least without a desktop, you're gonna see a bash, pretty certainly. I mean, some people like to change their configuration so that they get something like a Z shell or a C shell or whatever, but I think the overwhelming majority of Linux systems, when you open a command interpreter, it's gonna be the bash. Okay, this is still not done, but I don't want to wait forever, so I want to get through this chapter really, so I'll just at least continue copying these scripts. So another batch of scripts. And jump right back into it. This is getting exhausting. I'm doing this all day already. And here we go again. Okay, while this is still running, let's talk about these tools that we are installing now, or these packages. Yeah, libtool is a package that contains a GNU generic library support script. It wraps the complexity of using shared libraries in a consistent portable interface. So that's basically what you need to dynamically load shared objects, you know, the equivalent of DLL files. GDBM is a GNU database manager. The library provides primitives for storing key data pairs, searching and retrieving the data. So yeah, something like a library for hashing and stuff, to store data. gperf generates a perfect hash function from a key set. Okay, a perfect hash function is pretty hard to explain. So It's a tool that you use in some programming projects. I think it gives you an optimal way of checking. So like when you do something like a switch statement but over strings. Of course, in C and C++, you cannot switch over strings, but I think gperf generates something like that, and in an optimal way such that you will get to your selection in the shortest possible way, given the strings. Expat, C library for XML. inet utils, okay, that's some regular stuff like ping and telnet, FTP, traceroute, ifconfig hostname. Perl is a practical extraction and report language, is a programming language, relatively high level also. Again, something that I don't think should be in a low-level system like a Linux from scratch. XML parser. Okay, that's Perl interface for parsing XML files. Well, oh, I just see it's actually an interface to expat. So that explains why we have expat. Intel tool is for internationalization. So I think that's used to, it looks to me like this is used for actually automating internationalization stuff. Autoconf and automake, well, these are the so-called auto tools. They create these config scripts that we've been using all the time here, and the make files that we are using all the time. So that's that. Kmod is for communication with the kernel, for loading kernel modules, unloading kernel modules. So you have modprobe, insmod, rmmod. libelf is a library for handling ELF files, executable and linkable format. Okay, libffi. The libffi library provides a portable, high-level programming interface to various calling conventions. OpenSSL. Well, I guess you know this already. SSL is the secure socket layer. That's a very important library for encrypted network connections. And then Python. Well, Python is a scripting language, a pretty popular one, it's widely used these days. Again, it's pretty high level. I would actually rather prefer not to have it in here. But I think you need that for compilation of some parts. I think for systemd you need Python, if I'm not mistaken here. But again, as a purist, I would say if we could avoid having it, I would prefer to avoid it. Here I need to set a paper size. In Germany, A4 is the standard size of paper. In the United States, you might have letter. So you can configure that in Etsy paper size. So I'm gonna set this to A4. Interestingly, here we have a predetermined J1 because, well, apparently this has problems if you would run multiple compile steps in parallel. So this really forces us to leave it at 1. We cannot say LFS make jobs. Okay. Great. So okay, so now we run the last batch for today. Yeah, let's start this. And let's talk about these last packages. Okay, so Ninja. Ninja is a build tool like Make. It's a more modern build tool. I know that it's, for example, used in the Chrome project. So that is a testament to its quality, of course. Meson or Mason, I'm not sure how to pronounce it, is another build system, which I think is only needed for system D, but I don't know. Core utils, oh boy. What is not in core utils is the better question. So let me just show you. Almost, I would say half the system is in core utils. So what do we have? Base 64 encoding, the open bracket tool, which is a link to the test command. But well, in bash scripts, whenever you see if open bracket something close bracket, that open bracket, that's this tool here. Everything is in there. Base name, cat, change group, change mode, change owner, change root, checksum, copy, cut, dd, dir name, disk usage, echo, environment setting. Just look at it. It's everything. Everything is in here. The ID tool install is something that copies files with some more options. Link, the tool for making hard or soft links, directory listing, MD5 sum, make directory, make pipes, nodes, move, nice. Just look at it. It's so much in here. Printf, print working directory, read link, remove directory, different sum tools for different SHA numbers, sleep, sort. I bet unique is also in here. Yeah, there's unique. STTY, TTY is in here. Sync, which flushes system buffers. T. So many of these that I've already used in the scripts, you know. So timeout, translate, which can be used to turn uppercase to lowercase and lowercase to uppercase. Uname is also in here. WC, or I think word count, or what is it? Who am I? Yeah, so much stuff in core utils. Okay, check is a testing framework for C. Okay. Diff utils. Yeah, if you write programs, you probably know diff. So when you have two files, then diff will create a so-called diff file, which basically describes the difference between these two files. From file A and B, you create a diff file, something.diff. And with patch, you can apply that diff file to file A to make file B out of it. So that's very useful, for example, in Git. This is used for when you submit your changes, you don't submit your whole new files, you only Git just makes the diff from your old version to your new version and then only uploads the diff. And if you pull the changes, it actually only pulls the diff files and then patches your old files with these diff files to get the new files. So that's how you distribute your changes in a Git repository, for example. Okay, that's diff. GNU org. How do you describe org? It's a very powerful tool. I would describe it like a bit like a spreadsheet application. You can write small scripts and run them on CSV files. Not only CSV files, but that's a very common use case for org. And it's actually quite similar to C in its syntax. Okay, find. Find is another very useful tool. So with find, you can, well, find files. So for example, if I say find in the current directory something with the name something.sh, it will find all the shell scripts in here. the ones directly in the directory, but also in subdirectories. You can limit the number of subdirectories, so the depths you can set a minimum depth, a maximum depth. You can limit the creation date or the owner, all sorts of things that you can use to specify what you are looking for. Actually, for the longest time, I've had problems remembering the order in which you have to pass the parameters, because it's a bit unusual that you would put the directory where you are searching as a first parameter, and then have the different conditions that you are looking for after that. That's a bit uncommon for Linux programs, but it actually makes sense when you think about it in the way that the directory must be the first parameter, because you can have multiple conditions here. Like, I don't know, something that contains an E. Graph, processing and formatting text. I think it can produce PDF files. Yeah, you have to set a default paper size here that you can also change in etc paper size. Yeah, not something that I regularly use, but well, grub, the Grand Unified Bootloader. Well, that's of course the thing that we will use in the end to boot our system. So that's gonna be the bootloader that we will put on into the boot partition, but only later. So here we basically compile the tools that we will then use to install the bootloader. Like here, grub install, for example, is used there. Less is a small text file viewer. gzip, another compression tool. iproot is for, well, in networking you have this notion of a default router. So when you send something that's outside your own subnet, then it is sent to the default router. And iproot is necessary if you have more complex rules than that. So, for example, where I work, we have multiple routers, and depending on the IP address that we want to communicate with, it has to go to different routers. So then we would need static routes, which would be configurable with iproot. KBD is a tool with which you can select your keyboard layout. So you need to call this with a certain keyboard layout so that the Linux system will then recognize your keys correctly. Your load keys, that's the tool I'm talking about. libpipeline. The lib pipeline package contains a library for manipulating pipelines of subprocessors in a flexible and convenient way. I've never used that, but it sounds useful. I think I should look into that. Because when I write programs, sometimes I want to communicate with other programs, and it's a bit inconvenient the way I usually do it. Make, well, the big build tool that we are also using all the time here. Here we use make all the time here in these scripts here. I've just seen another make call that I haven't sped up. Okay. Yeah, very powerful tool. If you know what you're doing, it's you can do a lot of things with it to really explain your whole idea of the connections between your source files. I've used that to generate, to automatically generate a lot of stuff. So if you know what you're doing with it, it's a really powerful tool that, if you ask me, there is just no other tool out there that even comes close to its feature completeness. So I really don't know why there are any other build tools out there. Whoever thought we need a new build tool just didn't know how powerful make is if you know what you're doing. Okay, patch I've already explained. To apply diff files. ManDB contains programs for finding and viewing man pages. Okay, this is where man lives. I thought that would be somewhere else, but okay. Okay, then that of course makes sense, because man is the tool used to view man pages. I thought that this would have been part of man pages, but apparently it isn't. tar, another powerful compression tool, also used all over the place in the Linux from Scratch toolset. TextInfo contains programs for reading, writing, and converting info pages. Sounds like some form of markup translator, or markdown translator maybe. Okay, and Vim, yeah, very powerful and also very popular text editor. It's hard to get used to, really, because normally you'd assume that you start a text editor, you start editing your text, not in Vim. In Vim, it's more that you load a text file and then you kind of program the changes that you make to it. Okay, I started here, and now by pressing I, I've went to the editing mode. Okay. Then with escape, I've left the editing mode again, and now I'm in the normal mode again, where I could use :W to save the file, :Q to end the program. Since I've done changes to it, it wouldn't let me, so I would have to say Q exclamation point to say I don't care, I want to leave anyways. But just an example, colon D3 would delete the next 3 lines like this. Okay, so colon D just deletes 1 line. Q exclamation point. That's Vim. Nice tool, very popular among programmers. But of course, by praising Vim here, I've of course initiated another holy war because a lot of people prefer Emacs, and I don't even have it installed. From what I've seen, it was just too complicated for me. Okay, so that's all the packages that we are currently installing. And it only took me about 10 hours to go through all this. The Linux from Scratch book says the compilation takes, or would take about 5 hours on a system like this, but as I said, with the auto tests, I guess that's why it's taking so much longer now. And again, because I'm running it on a USB key instead of an SSD hard drive. So yeah. Okay, so this is everything I want to do for today. As I said, about 10 hours. I think that's enough for today. So yeah, if you like this video, like it, share it, subscribe. Maybe just like it for the sheer effort of doing this for 10 hours today. So I actually took a day off from work just for this. And yeah, tune in next time when we will go into the init system and probably also already in the system configuration. So then we will really go to the really interesting stuff. I'm really looking forward to that. See you next time. Bye.